All right, so we're going to give it a shot dealing with day 16, which does not have a lot of completions, which is not a good sign. But we will try to make it work. And if it doesn't work, like I said, I have other stuff to do today, so I'm not going to spend my entire afternoon on this. Blah, 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 blah. Risk a little while, so you made a program manual. It says for register, the community by instructions containing, I feel like this was a question last year too. 1 to 16 opcode, register, start with the value 0. Instruction consists of 4 values in opcode, 2 inputs, and an output in that order. Opcode specifies the behavior of the instruction, how they interpreted. The output C is always treated register, and the opcode if it says value A, it means take the number given as A literally. If something says register A, use the number given as A to read to or write from the register number. So the opcode add I adds register A and value B, storing the result in register C. It would add 7 to the value contained by register 0 and store the sum in register 3, never modifying opcodes fall into 7 categories. So the manual gives the name of each code, doesn't seem to hit the number, having a monitor CPO to see the content of the registers before and after instruction execute, try with them out. Each opcode has a number from 0 to 15. The manual doesn't say which is which. For example, so let's capture the following sample. 3211, 32. Instruction itself means opcode 9 was executed with 8. Opcode 9 can be in the opcode, only 3 of them can be even way the cost result. 9 can be R register 2. Sample behaves like 3 opcodes. You may collect many of these samples. The manual is called test program. How many samples in your puzzle input behave like 3 or more opcodes? Okay, so I think this will be manageable. Day 17, what's it called? This is 16. Day 16 chronal 16 chronal classification.py. Okay, so we have this massive pile of crap, and so let's just start this by saying from typing import list, and what are we calling this? According to the manual, the device has 4 registers manipulated by instructions containing 1 to 16 opcode. Okay, so registers is going to be a list of ints, we have an instruction. So class instruction is a named tuple. Named tuple. Just 4 values. An opcode is an opcode, which is I think a string, and 2 inputs named A and B, which are ints, and C is an int. The opcode specifies the behavior and how the inputs are interpreted. The output C is always register, and what is an instruction going to do? So let me not make this a named tuple. I'll just say instruction, because I'm gonna so how do I want to do this? So they're going to give me something it's going to be an instruction with actually, let me go back and do it like this. This is fine. And I'll just make a master list. So I want to what do they call this? Merely by instructions. Output is always treated as a register. Store C, store C, store C, store C, store C. Okay. So I'll just call this operate self on registers, and I'm just going to I'm not going to modify registers. I'll treat them as immutable, and I'll do this, and so this is going to be if self dot opcode equals add r, store into so, and let me just do output equals registers. So if we do add r and store into register C, output self.c equals output self.a plus output self.b. Okay, so and then if this is where you wish Python had a switch, add I, add register A and value B. So it's like that. And now I have mul r. So this is mul r. Stores in register C the result of multiplying register A and register B. And then I have mul I. Register A and value B. Okay, so bitwise and elif self.opcode equals ban r. So I can do bitwise and just like that, I think. I should be able to, right? 7 and 6 is 6 because, yeah. Okay, so that's fine. And then I have this guy, ban I, elif self.opcode equals ban I, bitwise and of register A and value B. So again, just do this, bitwise or register A. This is getting kind of tedious, but that's fine. Elif self.opcode equals bor. I'll just do this and let's see if people are there. Hi everybody. And then I have this bori stores into register C. This, so BORI, and value B. Okay, So, and then I have assignment. Set R copies the self.opcode equals set I stores value A in register C. So output self.c equals self.a, or no, copies sorry, I was reading the next one, equals output self.a, and then we have set I, which is set immediate. So that was set R. Set I stores value. How many of these are there? Okay, there's not too many. Greater than testing. gter register C0. elif self.opcode equals gter. If value A is greater than register B, then output self.c equals 1. Otherwise, output self.c equals 0. And then I have gtree, elif self.opcode equals gtri, sets register C to 1 if register A is greater than value B. So if output self.a is greater than self.b, output self.c equals 1, else output self.c equals 0. And then we have gter, which is just doing the same thing but with registers. So self.opcode equals gtrr. If output self.a is greater than output self.b, and I probably should have just made a copy and not called it output, but that's fine. Output self.c equals 1, else output self.c equals 0. Then I have equality testing. So equeer, elif self.opcode equals equeer. Set register C to 1 if value A equals register B. Output self.c equals 1, else output self.c equals 0. And then I have EQRI, which is doing the opposite. So elif self.opcode equals EQRI. If register A equals value B, so output self.a equals self.b, output self.c equals 1. Otherwise, set it to 0. Output self.c equals 0. And then the last one is EQRR, which is elif self.opcode equals EQRR. If output self.a equals output self.b, output self.c equals 1, else output self.c equals 0. Okay, and so one other thing I want to do is I want to list all the opcodes so I can iterate over them. So there's add R, add I, mul R, mul I, ban R, ban I, bor R, bor I, set R, set I, set R, set I, GT IR GT RR GT RI, and then same with EQ IR RI and RR, EQ RI, EQ IR, and EQ RR. So those are all the opcodes. And then what I want to do is say else raise value error unknown opcode self.opcode, make that an F string, and then return the outputs. So let me so let me run day 16 kernel falsification, return outside function. So that's not good. Okay, and so now in this example, I have let's say before equals this, and then I have 212. So I want to say for opcode in opcodes, instruction equals instruction opcode, and I say 212. 212, and what I want to do is I want to say print opcode and instruction dot, and what did I call it? Dot operate. Why is that not working? Instruction dot operate before. Name outputs is not defined. Why is that? Because I called it output, 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 output. Okay, so let me try this again. And so we want to check, so let's see. Instruction means the output could be any, but we want it to be 3221, 3221. So it could be mul r, it could be set I, or it could be add I. So let's see, mul r, set I, add I. So that looks right. None of the other opcodes produce a result because that the sample behaves like 3 opcodes. You may collect many of these samples. The manual also includes a small test program. The second, this is a lot. So let me split this into 2 pieces now. Okay, so let us go to data and do day 16a.text, paste that here, and now we need to parse this, and none of the other opcodes, you may collect any samples. How many samples behave like 3 or more opcodes? So we don't even need to worry about this. So let me think about what the smartest way to parse this is. And I'll just use this as my working thing to parsing code raw equals this. Okay, so we're going to use a regex, and my regex is going to look like the following. Regex equals, I want it to be before that, and then as little as possible before I get to that thing, and then new line, and then as little as possible before I get to another new line. And then after, and so before has 1, after actually has 2. And again, as little as possible before I get to closed brackets. So let us try this and see what happens. Paste re.findAll regex raw. And why is that? Re.all, will that work? No. I have a feeling like it's going to, it doesn't like that I have Python regex with new lines. Ross backslash not handled special way, so that is a 2-character string while slash n regular sessions. What if I just try this and see if that works? No. It doesn't work. So let's re.match. Let me just try this. And raw. So that doesn't even work. So what is raw? I have before colon, and I'd screwed this up before too. I need to, God damn it. Okay, so I screwed this up last time, and I need to escape these square brackets. So okay, so that so re.findAll regex raw. Okay, so that works. Okay. So let's come up with an example here, which is a named tuple, and it is going to have a before, which is registers, and it's going to have an instruction. It's actually not going to have an instruction, and it's going to have I'll call it a pre-instruction, which is a list of ints, and it's going to have after, which is a registers, and so def parse raw, which is a string, and I'm going to return a list of examples. And so what am I going to do? I'm going to say for before bpia in re.findAll regex raw. What do I want to do? So B will be like this, and so I want to say before equals int x for x in b dot split on commas, and similarly after equals int x for x in a dot split on commas, and then pre-instructions equals int x for x in pi.split, not on commas. And so let's say examples is this. Examples dot append example before, pre-instructions after, and then return examples. And so let's say examples equals parse the raw, and so let's run this thing again, and let's look at the examples. So before 3, 1, 0, 1, pre-instruction 9, 3, 3, 2, after 3, 1, 0, 1, and then after, yeah, so that looks right. Okay, so now let's do count. We want to count possible ops, which is going to take an example, and it is going to return a list of strings. And it's just going to tell us return opcode for opcode in opcodes if the instruction given by opcode and so let's say whatever ABC equals example dot pre-instruction. So the first one is remaining anonymous. So opcode ABC dot operate on example dot before equals example dot after. Okay. And now for example and examples, print example possible ops example. So this guy, we're saying that to get that, he could be this and this. This guy, he could be this and this. And then, we had this other one that we tried that that was this one. And so let's just make sure that it behaves well too. So I'll make this my first example. And I lost my before. And so let me run this. And now it's saying add I, mul r, set I. So that's what we said. Okay. So now what we want to do is we want to say with, and so the question is, okay, so let's take a step back. We have this notion of an instruction which has an opcode and 3 things. We have all this logic of given one of these instructions and registers, which is 4 ints. How do I operate on this? And I operate on it and return a new set of registers because I don't want to mutate things. That would make things more difficult. I've written code to take this and just parse it into before registers, after registers, and these instructions. This first one, we don't know what it means. Probably in the second part, they'll tell us to figure that out. And now we want to know which of these examples could this thing represent, I think, 3 or more ops, right? So what we did is we wrote a function that says, given an example, a before, after, and something that looks like instructions without knowing the opcode, what are the possible ops that it could be? And so now we just need to data day 16a.text. Is that right? Yes. As f, let's say raw equals f.read. Examples equals equals parse raw, so we can do that. And what we want to do is we want to print the length of example for example in examples, example for example in examples, and we only care about the ones where if len of possible ops example, so we want that length to be at least 3, right? Is that what they're asking? Examples behave like 3 or more opcodes. Okay, so let us run that, and it says 618. And were there that many examples in my input? I guess there were. Okay, 618. So that's not the right answer. It's too low. Curiously, it's the right answer for someone else. Either you're logged in to the wrong account, unlucky, or cheating. In any case, you need to be using your puzzle input. If you're stuck, there are some general tips on the About page. Okay, well, I'm not cheating. You watched me do this, so you're either logged in. I'm not logged in the wrong account. I'm not cheating, so I must be unlucky. So let me try saving this whole thing, because with the regex I have now, it'll be fine. And let me try running it again. It still says 618. So the real question is, did I screw up the logic? Because clearly I'm unlucky. Okay, so one is I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so again, I have 16, so that's the right number. And my opcodes look pretty good. So self A plus output self B, output A, okay, so output plus output, okay, bitwise and, bitwise or immediate. Set contents of register A into contents of register C, set value A into register C, set register C to 1 if A is greater than register B, otherwise 0. Sets register C to 1 if A is greater than value B, otherwise it's set to 0. GTRR sets register C to 1 if register A is greater than register B, otherwise 0. If value A is equal to register B, set it to 1, other 0. Register A is equal to value B, otherwise 0. Sets register C to 1 if register A equals register B. So that seems right. So let's inspect a few of these. So let's comment this out, and let's say for example in examples, let's look at the first 10. Print example for opcode in opcodes. So let me do this again. Inst equals instruction opcode ABC. Output equals inst dot operate example dot before print print opcode and output. So that should be fine. So let me run this again and take a look at these now and see. So before this, I have 332. And actually, rather than printing the opcode, I'm actually going to print the instruction. I think that'll make our lives a little bit easier. Okay, so we start with 3101. So here we're doing things to register 2, which is the third one. So we want to add register 3 to it. Or no, we want to add these registers. So 3 and 3 is 1 plus 1 is 2, so we set it to 2. That's good. We want to add immediate. So we want to add 1 plus, and is the immediate doing B or A? The immediate is doing value B. Okay, so 1. So now we want to do 1 times 1, 1 times 3. That's right. Bitwise and 1 and 1. Bitwise and 1 and 3, which is still 1. Okay, bitwise or 1 and 1 is 1. Bitwise or 1 and 3 is 3. Okay, that's right. Set writes, set to the register, set to the value of 3, so that's 1. Set to the immediate value of 3 is 3. Greater than 3 and 3 is, sorry, immediate, right. Is 3 bigger than 1? Yes. Is 1 bigger than 1? No. Is 1 bigger than 3? No. Are they equal? No. Are they equal? No. Are they equal? Yes. EQRR. So that seems to be wrong. So why would that be the case? So output self.a equals output self.b. That's got to be true because self.a and self.b are the same. Then output self.c equals 1. So EQRR is not doing the right thing. And here again, EQRR is registered 2. So it's definitely not doing the right thing there either. Okay, print self output. And so that's even just the first one. So let me just go here and just do that and run it again and look at it. And so why did it not do that? Did I get one of my EQR? So something weird is going on here. So print opcode self.opcode. And no, something is showing up. Oh, that should show twice because I did print self. So let me try this one more time. And let me not do that. And let me just run that. So that's saying that gets here, that gets here. So why is it not something really screwy is going on here? output self.a, output self.b. Let me try that. 1, 1. And finally, output self.a equals output self.b. True. So print yes output, and now print output. So run this. Yes, that. Self.c. So how on earth is I'm saying okay, print output, print about to set output self.c equal to 1, print output. There's something like 0, 1, 2. Yes. Okay, so now it is doing the right thing. $6.36. Okay. That is the right answer. Okay, so I made a really stupid mistake where I was using double equal instead of single equal. Using the sample you collected, work out the number of each opcode and execute the test program, the second section of your puzzle input. What value is contained in register 0 after executing the test program? Okay, so so what do I want to do? I want to say candidates equals and how many different are there 16 of them or not? No, it goes up to 15, right? Yeah. Okay. So candidates equals I opcode, and I'll make a copy of opcodes. Actually, you know what? I'll make a set of opcodes for I in range 16. Okay, so and so what I want to do is the following. For example, in examples, and let's say code ABC equals example.pre-instruction, and now what I want to do is say let's say to remove is equals a set for opcode in candidate's code. So if this guy says he's opcode 9, we'll say what are the things he's allowed to be. Inst equals instruction opcode ABC, output equals ints dot operate on example before. If output is not equal to example dot after, then to remove dot add opcode. And now what I want to do is I want to say candidates code equals opcode for opcode in candidates code if opcode not in to remove. So again, it's hard to remove things while you're iterating over them. So what we'll do is we'll just say, let's make a set of things to remove, go through. If you produce the wrong answer, we're going to remove you because you're not a candidate. And so I'll just go through and do this. And so let me run this and look at the candidates. And I have way too many candidates. So why is that? In fact, I barely eliminated anything. So that's not right. 778 examples. So let's figure out what I did wrong. I do pre-instruction, I do to remove for opcode in candidates code. Figure out the instruction, do the output. If output so let's just print code, candidates code. To remove. So let's just do this and see how it runs. And so print example and print opcode comma output. So this is just going to print a lot of stuff now, but let's check it out. So this does this, pre-instruction is that. So I want to do something to so this is 13, so it goes 2230, 2231. It's doing register 3. So let me print example and print candidates code. That will be good. So let me run this again. And say here's an example where we are changing the second one to 0. And these are the things we're considering. So if I do greater than register, the instruction is actually register 0 and register 2. So register 0 and register 2. So that'll be a 0. So 1 and 2 are using the samples you collected, work out the number of each opcode. So I know that's all correct. So I must have a logic error here. So for each example, this is a pre-instruction to remove equals the set. candidates, so I get the pre-instruction, I get to remove for each opcode that is still remaining. I want to work out that instruction, operate it on my before, and if it is not if it's not equal to the example after, then I need to remove it because it doesn't work. And now I have these things to remove, so I say candidates code equals opcode for opcode and candidates code. If opcode not, and to remove. So, for example, print candidates code and print to remove. So let's try that and run it. So my to remove is almost always empty. So somehow somehow that's not right, and it's not right because a lot of these involve setting things to 0, and there's a lot of ways to set things to 0. But it's still shocking that so let's find one where to remove is not 0 if we can, and so we can't. So let's just look at the first 10 again and run this. So we start here, and we're working on position 2, which is the last one. Nothing happens. We do this, and let me print all this. Print inst output example after. And was that just the first one I was looking at? It was. So let me just even change this to the first one and just look at it in detail. Example dot after. Okay, so here's all my outputs. And actually, you know what? I think I've probably not done anything wrong, but I need to do something that's smarter, and which is the following. Like, let me just so are there any candidates that are unique? Yeah. So 5 has to be EQIR. So that means that once I know that, I can remove that from everyone else, and that's probably what I should have done. So what I need to say is if len of candidates code equals 1, then my opcode equals and I should not have used sets because that will it's a pain in the ass to get things out of a set. So I'm just going to do this, and I don't think I ever used that they're a set. So and I'll change that to less comprehension. My opcode equals candidates code 0, and now for I in candidates, if I is not equal to code, which is this one, then candidates I equals opcode for opcode in candidates I if opcode is not equal to my opcode. So basically, here's an extra step where I say, if after doing this thing, I've said I must be, mul r or whatever, then necessarily I can remove mul r from everyone else. So let me, my opcode is not defined. And I made the same stupid mistake I made before. Okay, that's okay, so good. So now I have candidates. Okay, so that's good. And now we need to get this program out of here. So what is the program? And here's like 3 new lines. So what value is contained in register after executing the test program? Okay, well, the question is, what do the registers start with? Start with a value 0. Okay, good. So I'm just going to copy these over into day16b because that will make my life easier. And let's do day16b.text and save that. And so now let's say code code to opcode equals this. For code opcodes in candidates.items. Let's say assert that len of opcodes. Actually, I don't need to do that. I'll just say assert that all len of codes equals 1 for codes in candidates.values. So that's fine. And now what I want to do is I want to say do I want to write with open data day 16b.text as f. Let's say instructions equals this for line in f. So let's say code ABC equals line dot split, and I want to do int x for x in line dot split. Opcode equals candidates code 0 because we know there's only one of them, and then instructions dot append instruction opcode ABC. So let's try running that and do instructions. Instructions -1 is adder 200, and I think let's make sure that's what we have. Adder, well, it's something 200. Okay, so that's good. So now what I want to do is I want to say registers equals 0000 for instruction in instructions. Registers equals instruction dot operate on registers, and then what value is contained in register after executing the test program. And now let's print registers. So let's go over and run this, and it says it's 674. So let's try 674. And that is the right answer. And I've completed day 16, and I'm not on the leaderboard because I'm doing it the day after, and because I've made some stupid mistakes along the way. But I was able to get it to work in about an hour, thanks to your guys' help. So good. So get status. Let me rename the day 15 one uncompleted because I didn't complete it. So get add data, get add day 15, get add day 16, get status, get commit m day 16, get push. So that one worked, which I am happy about because yesterday was not a good advent of code day, but today was not a terrible advent of code day. So I think I already talked through most of this and how it worked, and I think it makes sense. The key thing that I got stuck on a little bit was not doing this extra step to say once I've gotten one of them where this one must be add-r, therefore let's eliminate add-r from all the rest of them, and that kind of allowed us to bootstrap down to making it work. So that made it work. So that's good. So anyway, this is all up here on GitHub. You can find me on Twitter, on YouTube. You know how to find me if you're watching this, and you can find me on Patreon. So that is it for today, and it's possible I will do it tonight for the next day. Depends on how my day goes and how much of my work I get done. I have a lot of stuff I need to do. So thanks for watching. That has been your Sunday afternoon edition. Cool. I'll see you guys next time, which might be tonight.